Today we start with the new chapter, it is matrices. So, what are the different subunits for this chapter matrices that we see here? So, in the first part, that is the elementary rows operation and column operations. So, this part has been deleted from the course. So, we directly come to the different methods. So, here reduction method for the inverse of the matrix A, and there is another method, that is the adjoint method, but as transformations are deleted, so this reduction method is also deleted. Therefore, we refer here the adjoint method to find the inverse. So, first of all, we discuss here some basic ideas how to find the minors and cofactors, which is very important for to find out the inverse of the matrix A. So, first of all, what is minors and cofactors that we see? So, here we take the general example to find the minors and cofactors for the matrix A having the elements A11, A12, A21 and A22. So, these are the elements in first row and these are the elements in second row. So, how can you find out the minors of each element of this matrix A? So, that we write here, minors of each element of the matrix A is denoted by Mij. So, what is this symbol Mij? Mij is used for minors where these abbreviations I and J, where I is equal to 1, 2, 3, I represent, which represent the rows, and J is equal to 1, 2, 3, this represent the columns. So, these are the basic ideas that we have seen in the 11th standard. Further, cofactors. So, on the basis of minors, once you get the idea of minors, very easily you can find out the cofactors from the minors. So, orally we can determine the cofactors, but there is a formula to find the cofactors here, that cofactors of each element denoted by Aij. So, this is again a symbol for cofactors. Aij, I and J are the abbreviations, suffixes, they are used for the column and row again here. So, here I represent the row and J represent the column. Now, so we find the minors and cofactors, but particularly the formula for cofactors that is given, it is written as Aij is equal to minus 1 raised to the power I plus j into Mij, means your cofactor is equal to minus 1 raised to the power that is the number of rows plus number of columns into order of this minor already obtained previously. So, this is the formula, but every time we need not use this formula, how to find directly cofactors, that we see further. So, for that we take here the minors of this matrix A. Already we have taken the matrix A here as a general example, and these minors are denoted by Mij. So, how can you find the minors of this matrix? Here minors M11 is equal to A21. So, what is the meaning of this? Minor of the first element, that is A11. So, therefore, suffixes I is equal to 1 and G is equal to 1. This is the minor of first element A11 and that is equal to A21. So, how can you find out this A21 here? Here we want to read here A22. So, how can you write this A22? So, while finding the minors, so this element is required here. We want to find out this minor of this element. So delete the elements in rows and delete the elements in column of that element. So what is the remaining element? That is A22, and therefore we have written minor of first element, that is M11 is equal to A22. Similarly, this process to be adopted throughout this problem here. Again, in the first row, second element is A12, that is first row, second column. So we want to find out the minor of this element here. So it is denoted by M12. So that we have written here, minor of that element is M12, and minor of this element is A21. So that is written here A21. So again, we know that we delete the elements in that particular row and particular column. So what is left there? A21, and therefore minor of this second element M12 is equal to A21. Similarly, that first row has been completed here. Now we come to the second row. In the second row, there are two elements A21 and A22. So we want to find out the minor of this element. So again we adopt the same process. We delete the elements in rows and we delete the elements in column. So what is the element left here? A12, and therefore minor of M21 is A12. Next, last element is A22. What is the position of this element here? This is the element in second row and second column. So we want to find out the minor of this element. Again we use the same process. We delete the element in rows and column. So what is left here? A11. So minor M22 is A11. So in this way we can find the minor of every element of the given matrix. So here we have taken the simple example, that is the 2 by 2 matrix. This is 2 by 2 matrix, 2 by 2 matrix. In the next example we further consider the example on 3 by 3. But corresponding that is the cofactors, how to find the corresponding cofactors of these minors. So we have the formula, cofactor, that is Aij is equal to minus 1 raised to the power I plus j into Mij. So we find the cofactor of M11. So what will be the cofactor of this first element? That is denoted by I is equal to 1, j is equal to 1. Therefore A1 is equal to minus 1 raised to the power I is equal to 1, j is equal to 1. So what is this? First row, first column, that is 1 plus 1 into the minor of this first element, that is A22. So into A22. So minus 1 raised to the power 1 plus 1 2, minus 1 square is 1, and therefore I have directly written here 1 into A22 is equal to A22. So this is the cofactor of the first element here. Now we come to the cofactor of the second element. So what will be cofactor of second element? So first of all, determine the element in which row and which column it exists. So it is in the first row and second column. Therefore according to the formula, minus 1 raised to the power first row, that is the first row and second column, first row and second column. So we know that 1 plus 2 is 3, minus 1 raised to the power 3 is minus 1 into the minor A21. So minus 1 into A21 is equal to minus A21. So this is the cofactor of the second element. Now we come to the cofactor of the third element, A21. So again always determine the number of rows and columns. So here it represents the second row and first column. Therefore we put in the formula minus 1 raised to the power. Again we have made the mistake here, that is I is equal to 2 and j is equal to 1. I is equal to 2 and j is equal to 1. So it is 2 plus 1 is 3 and minus 1 raised to the power 3 is minus 1. So minus 1 into A12. A12 is equal to minus A12. So this is the cofactor of the element in second row and first column. Now we come to the last element, that is this element in the second row and second column. So here determine second row, second column. So it is equal to minus 1 raised to the power I is equal to plus 2 and j is equal to 2. 2 plus 2 is 4, and therefore minus 1 raised to the power 4 is 1 itself, and 1 into minor, that is 1 A12, that is equal to A12. So in this way we can find the minor of the last element A21. So this is the process how to find the minors and the cofactors using this formula for the cofactors. Aij is equal to minus 1 raised to the power I plus j into mij. So this is the process to find the minors and cofactors. We take the particular example for this. Find the minors and cofactors of the matrix A. So here your given matrix is, again this is matrix of 2 by 2, means there are 2 rows and 2 columns, 2 rows and 2 columns. So we find by process minor of 1. So it is the position of 1 is in the first row and first column, therefore minor is denoted by M11. And by the process delete the row elements in rows and delete the elements in column of the 1. So what is left? That is 4, and therefore M11 is equal to 4. Then first of all we find all the minors here. Then second element, this is the element in first row and second column. So again we delete the elements in rows and columns. So what is left? There is 3. So therefore minors of element M12 is equal to 3. Then we come to the second row and first column. So it is M21. So again we delete the elements in rows and columns. So what is left? That is 2. So we have written M21 is equal to 2, and that is last M22. So again delete the elements in rows and column. What is left? That is 1. So this is the minors of the element in the second row and second column. Now we find the corresponding cofactors of these minors here. So here this is according to the formula. This formula has been given here. Aij is equal to minus 1 raised to the power I plus j into the minor of that element. So that we apply here. Again determine the row and column, first row, first column. So I is equal to 1, j is equal to 1. Minus 1 raised to the power 2 is 1. 1 into that minor, 1 into 4 is 4. So this is the corresponding cofactor. Again minor of this cofactors of this minor, that is given as A12, and it is minus 1 raised to the power 1 plus 2, that is 3, and minus 1 raised to the power 3 is minus 1. Minus 1 into 3 is minus 3. Then M21 having the cofactors A21, and here I is equal to 2, j is equal to 1, minus 1 raised to the power 2 plus 1, that is 3, minus 1 raised to the power 3 is minus 1, minus 1 into the minor, that is 2, that is equal to minus 2. And last one, that is the minor is 1, therefore A22 is equal to minus 1 raised to the power 2 plus 2 into minor is 1, so it is into 1, minus 1 raised to the power 4 is 1, 1 into 1 is 1. So in this way we can find out the minors and cofactors of these given elements of the given matrix. So this is the process how to find the minors and cofactors of the given matrix. So in the simple language I can say, without using this formula, we can find the cofactors of these minors here. So I take this example orally here. So always remember here 1 plus 1 is 2, that is even number, 1 plus 2 is 3, that is a odd number, 2 plus 1 is 3, that is a odd number, and 2 plus 2 is 4, that is even number. So one thing you have to remember here, if the sum of row and column is even, then minor, that is equal to 4, is a cofactor, that is also 4. If sum of the rows and column is odd, that is 1 plus 2 is 3, then there is a change in sign. As the minor is plus 3, your corresponding cofactor will be minus 3. Without using the formula, we can determine the cofactors here. Again here, minor is 2 plus 1, that is 3, it is an odd number. So minor is 2, therefore there is change in sign, therefore it is minus 2, cofactor is minus 2. Similarly, this is 2 plus 2, 4, this is a even number, so minor is 1, therefore minor is a cofactor, so your cofactor is also 1. So in this way we can find the minors and cofactors of the elements of the given matrix. Thank you.